Hello students, I am A.FATMI. In the last class, we discussed about the continuous gradient centrifugation. Today we will discuss about the rate zonal centrifugation. This is slightly different from the continuous gradient centrifugation in terms of the type of gradient present here. In the last class, in the continuous gradient centrifugation, the centrifugal tube contains the medium whose concentration or whose density increases uniformly from top to the bottom. Here, the concentration gradient increases in a stepwise manner. For example, or in different zones. For example, here in this zone, the minimum density of the medium is present, or in other words, the medium has the minimum density zone here, and we discussed about that the density gradient is formed or increased by increasing the concentration of the solute or the solvent or medium. That means in the top layer or top zone, the concentration of the medium is 10%. So this zone contains the medium whose density is least or whose solute's concentration is minimum, that is the 10%. Okay. The next zone, which is present just below this one, this zone contains the density which is higher than the preceding zone. Okay. That means the density of this zone is greater than that of this zone. Here, the concentration of the solute, for example, we are using sucrose, which is very much used for differentiation of subcellular particles or macromolecules like protein. Okay. So, for example, suppose we are separating the different protein molecules from a homogeneate, then we can use sucrose. Okay. Generally, 10% to 60% sucrose is used. 10 to 60% sucrose is used, and in the top layer 10% sucrose present, giving the medium and minimum density. Here the second layer, the layer below this one, contains a sucrose concentration of 20%, and its density is higher than the layer present on top of this, above this layer, this zone. Okay. Similarly, this zone has a density higher than this one. This zone has a density higher than this one, and this zone has a density higher than this one, and this zone has higher density higher than this zone. Okay. So that means the density is increasing in a stepwise manner, and different zones are present. Different zones are present whose density are different. Okay? Or in other word, zones of different density are present in the centrifuge tube, which is increases from top to bottom. One thing. Second thing, the range of density of the medium is selected in such a way that the range should always be less than the range of density of the particles of the homogeneate. Suppose we are using 10% to 60%, that means this range of density should be less than the range of density of these particles. That means some of them must have heavier than this. Okay, so this range should be less than the range of density of these particles, so that at any movement when the particle moves down the centrifugation tube, then the particle never reaches its isopycnic point, and all the particles always remains in a density zone which is less than the density of that particle own density. Okay, so this is the basic idea. That means that the density of the particle should always be greater than the density of the medium. That means that density of the particle at any point has a higher density than the density of its medium. Okay, so this is the basic idea. Okay, in this case, in the continuous gradient, the formation of continuous gradient, the gradient is created in the industry laboratory by machine. But in this case, this type of gradient can also be created manually. Okay, how with the help of pipette. Suppose we take 60% sucrose and pipette it out in the test tube, in the centrifugation tube. The 60% sucrose will settle over here. In the next step, 50% sucrose is taken and is pipetted into the tube, and the 50% sucrose is because it is lighter than this one, it will settle over here. Similarly, in the next step, 40% sucrose is taken in a pipette and poured into the test tube, and it will settle over here, forming a zone of 40% sucrose medium. Okay, whose density is less than this one. The density of this zone is less than this one. Okay, in the next step, further step, 30% sucrose is taken in the pipette and poured into the same test tube, and it will settle over 40% sucrose and forming a zone over here. In the next step, 20% sucrose is taken and poured into the test tube. The sucrose will settle over here, forming a zone over the 30% sucrose, and in the last 10% sucrose is taken and poured into the test tube, and it will form a layer over here. 10% sucrose zone, 20% sucrose zone, 30% sucrose zone, 40%, 50%, 60%. That means the density is gradually increasing from top to bottom, and the density is not increasing. Density is not continuous, but it is stepwise manner. Here, density is minimum, slightly higher, slightly higher, slightly higher, slightly higher. ठीक है? The maximum density is here, minimum density is here, and in between the intermediate density is present in the increasing order in the stepwise manner. Okay, so this is the medium, and in this case, that is the same. That the red zone centrifugation is also, that is why it is also known as discontinuous or a step gradient centrifugation. This is discontinuous, not continuously. It is in a stepwise manner. That means it is discontinuous or a stepwise manner. Gradient and centrifugation. Okay, the density of the medium increases from top to bottom in a stepwise manner. ठीक है. In the next step, what I am saying, okay, the density gradient can be created by manual pouring of a stepwise gradient with the help of pipette. Okay, a stepwise manner we will pour the medium in a stepwise gradient medium manner. Okay, manually using pipette. Okay. And the third point is the density range of medium is always less than the density range of the sample. Okay, I have already told you, we have already discussed that. Okay, and in this case the particles are separated due to differential sedimentation rate. That means that the particle which has more density or greater mass will move faster here and will settle down towards the bottom of the tube, and the lighter particle will remain above the heavier particle. Okay, so this is the basic idea. Sedimentation will take place due to differential sedimentation rate. We have already discussed what is the sedimentation rate, what are the factors influences the rate of sedimentation. Okay, so that means K separation in the step rate zone or a step zone. Centrifugation, the differential rate of sedimentation is the cause of separation of molecules. Okay, and we have seen, we have discussed, we have known, we know that the sedimentation is largely influenced by the mass and density in the case of sedimentation, for the rate of sedimentation. That means during the sedimentation or centrifugation, this sedimentation rate is influenced or depends upon the mass and density of the particle. The heavier particle having large mass, greater mass or greater density will move faster or will settle in towards the bottom of the tube, and the intermediate particles above the heavier particles, and the lightest particle will be at the top, towards the top of the tube. Okay, so this is the idea. So during centrifugation, what happens? The particles of different mass and density will settle in different density zone. Okay, so suppose this is the tube containing the different zone, and we add or pour the homogeneate or sample containing different particles or different protein molecules. This is the sample added at the top of the centrifuge tube. Because the particle is heavier than this medium, the particle will start moving down the tube. When we centrifuge at high speed for short period, or this is important, short period, the heavier molecule will move towards the bottom and settle over here. The intermediate particle of intermediate mass and size will settle over here in this zone, and the lightest particle will settle in this zone. Okay, so as the cell centrifugation takes place, these proteins or the particles present in the sample will form discrete bands or settles in different zones. But the centrifugation is carried out till the particle homogeneates get settled in the discrete zone. This is important. The duration is important. The duration should be long enough that so that these particles get separated from each other and form different bond bands will be visible from outside as well. Okay, so once these bands are formed or the particles are separated from each other, the centrifugation should be stopped. Otherwise, because the particles are heavier than these, more and more particles will settle down or will come towards the bottom and the separation will be incomplete. Okay, so once the separation happens or the bands are formed of different particles, components according to their mass and density, the centrifugation should be stopped. Okay, and the particle gets separates. So what is the difference? So this is the process in which the protein molecules can be separated or subcellular particles can be separated using sucrose, different concentration of sucrose forming a step gradient, density gradient in the centrifugation tube, and the particle forms different bands in the tube according to their mass and density. Heaviest particle will settle towards the bottom and the lightest towards the top of the test tube, and intermediate in between these two layers. Maybe more than 3 bands, 4 bands, depends upon how many types of particles are present, how many types of proteins are present. Once these bands are formed, centrifugation is stopped. Okay, so this is important. The duration is important. Duration is important. Otherwise, most of the particles will settle down at the bottom of the test tube, and the purpose will not be served or separating the molecules. So these are all about the red zone centrifugation. We discussed both continuous and discontinuous gradient centrifugation. Okay, hope you would have understood this. In the next class, we will discuss about electrophoresis. Okay, thank you very much.